So we're back again for some more Anki. Unfortunately, um, I'm not sure if I mentioned this last time, but I think we've already kind of established. I think there's going to be a lot more limited of content than originally I had planned. Um, so it's probably going to be a lot of studying like this. U World, I don't think I can't show it on here. So I'm probably just gonna need to do that on my own. Um, like I wish there was like an exact like pathway or like it was possible to make some kind of formula and maybe I'll come up with it along the way. But um yeah, I think like I don't even know if I said hello. Hey everyone. So thank you to anyone who came into the stream. Uh yeah, I mean like today I just wanna finish. I low key like I've been really debating whether what I wanted to do in terms of like what subject to work on next. But I think probably today might just be a day. I wanna do a lot of cards, but obviously by this point I think we've all come to the conclusion that I aim a lot higher in the beginning than I actually end up doing at the end of the day. So we're gonna do as many cards as we can. I have the maximum set to 300. I'm not making it to 300. I just have it set as that so that I don't feel like honestly I'm maybe I'll if I can honestly I obviously bare minimum 50 bare minimum bare minimum 50 cards. Obviously at the best I would finish chemistry and then maybe I don't know do like 20 psych soc something like that. Um, that would be amazing if I could do that. Um, I haven't even I don't know why I have physics completely closed. We haven't even worked on that. Um, but I don't know if I see myself opening that right now. Um, I hate like physics definitions. I feel like they're just better taught using questions or something like that. Um, all right, so We're we're pretty close to done. We're 40 no, we're 58% through the normal chemistry deck. Um, we haven't really done a lot in Orgo, but we'll definitely get there. But we should just finish chemistry first, in my opinion. Um, and yeah, let me put on Lelo-Fi. All right. Uh, yeah, that seems to be a decent volume. Is that too low now? That might be too low now. Yeah, I'll put that. Yeah, that looks good. All right, let's get it. Okay. Breaking bonds is what? Why does it say 14 cards? Oh, I clicked on. All right. Did I change? Let me see if I changed the order or something like that. Um, I'm a little confused here. 1 second. Um, I Okay. All right. Breaking bonds is generally uh breaking bonds. To break a bond is pretty stable. So when you break it, it releases energy. Or actually, no, it doesn't. It would absorb energy to break it. So it'd be endothermic. Yeah, we could press good. We don't really. Making bonds is generally um making bonds is generally exothermic. What is bond dissociation energy? It's the amount of energy necessary to overcome a bond between two specific atoms. Yeah. This one is in the gas phase too. How does one find the enthalpy of a reaction using only bond dissociation energies? Um uh I mean, I would assume you would just add them up, to be honest. The bond dissociation energies. Okay, I don't know. Add them up, bro. I don't know. If bonds broken minus bonds formed. Okay. I should have remembered that. What is standard enthalpy of combustion? We kind of done this. Standard oh, that's why. This is in the same deck. What is the standard enthalpy of combustion? Standard enthalpy of combustion is mm, I don't know, bro. Uh, this is the energy required to break a bond between for a substance in its gaseous state. Yeah, I give myself a hard for that. What is entropy? Entropy is chaos, spontaneity. Spontaneity of energy at specific temperatures. Okay. What is the second law of thermodynamic state in basic terms? I don't know. I have not a clue. Energy will always spontaneously spread out if it's not actively being kept from doing so. Okay. There must be an easier way that this is phrased. One second. Law of thermodynamics. This was the basic terms, by the way. That's crazy. The total entropy. Honestly, I feel like the actual definition is more basic than the definition they gave. To be honest, I would literally rather this definition. How does one find the enthalpy of a reaction using only bond association energies? Enthalpy bonds broken minus enthalpy of bonds formed. What is the standard enthalpy of combustion? It is the heat required for combustion to occur for substances in their standard states. and in constant pressure. What is entropy? Entropy is of the spontaneity of a system in like at a specific temperature. How do we calculate the change in entropy? Um, how do we calculate the change in entropy? Um, Damn, hold up. Let me okay. Before we continue, because I wanna just click on this. Oh no, not that. Click on this so that it's organized, but I don't think I have all of the decks organized, which is a little bit of a problem. Um, 1 second. Maybe not 1 second. I might need a couple minutes here. Thermochemistry. I think thermochemistry is probably good. I'll do this one first. Okay. Okay, that looks like that's already ordered. Then that also looks like it's already ordered. This also looks like it's already ordered. And that kind of also looks like it's already ordered. Okay. How is this 186 turns? Am I bugging? All right, we'll just click this. Um, what is the second law of thermodynamics state? Um, it states that second law of thermodynamics. Um, it states that the spontaneity of a system or in the universe will always increase, pretty much. Okay. Um, I was a little wrong, but how do we calculate the change in entropy? Mm, how can we calculate the standard entropy of a reaction? I don't know. I don't know. Is that entropy of formation? Is that what the F stands for? I think it is. Okay. What is bond association energy? Bond association energy is the energy required to break a bond. energy required to break a bond for substances in their gaseous states. What is the second law state? In a spontaneous process, the spontaneity of a system or the universe will always increase. Damn, I'm yawning a lot. What is? How do we change the entropy of how do we calculate the change in entropy? Um, the heat of the system divided by the temperature. Did I say system? I might have said system. How does one find the enthalpy of a reaction using only bond dissociation energies? Enthalpy of bonds broken minus enthalpy of bonds formed. How can we calculate the standard entropy of of a reaction? Um, it is the entropy of formation of the products minus entropy of formation of the reactants. Obviously, both of those are in their standard conditions. Breaking bonds is generally, uh, if you break it, it takes in energy, so endothermic. What is the standard enthalpy of combustion? It is the heat required for combustion to occur um, at constant pressure. Constant pressure. I didn't say in standard conditions, but like, I feel like I knew that. I'll click hard, but making bonds is generally exothermic. Why did that one give me 10 days, but the other one gave me 8? It makes no sense. I don't really like. I'm not gonna lie. Right now, I'm not really liking this FSRS because it's kind of like I also like I might underestimate myself, but that is what the algorithm seems to think that my memory is like really solid or something. Because Jesus, what is entropy? Entropy is the spontaneity of a system. Um, at a specific temperature. Okay, I'm actually gonna give myself an again because I want a more precise answer. How do we calculate the change in entropy? Um, Change in entropy would be um, mm, change in entropy is I don't know, entropy of uh, products minus reactants. Damn. You see, I don't know, bro. What is the equation to calculate Gibbs free energy? This is like I'm gonna just go for something. It's delta G, right? Is equal to I think it's like H something. It's something there, but I don't remember. Um Minus uh T delta S. That's my guess. Yo, oh my god. Okay, I might have gone through these. I didn't look through them, but like I was clicking through the cards to see if they were long. Maybe I accidentally remembered this. Like maybe maybe I accidentally memorized this or it refreshed me just enough to remember what this was. I'll give myself in again. What just because it was the first time. Because if I click on hard now, it's gonna give me it in 18 days. What is entropy? Um and I've already tried, like some people might think like, oh, have you tried some people might think like, oh, have you tried sorry, I got distracted by my friend coming in the chat again. So damn, I completely forgot what I was saying. Um mm, oh, some people might think, oh, have you tried optimizing your preset based off of your reviews? Right now, I think that the numbers are already crazy and the numbers are only going up. Like, I don't know if it's just that I don't know, maybe I'm not doing enough cards, but I have it set to like 90% retention. And the amount of days that I need to go to hit like 90% retention is this. And when I optimize it, the number of days goes up. I don't know, man. I think I don't know. Something's up here, bro. I might need to change it to like 95% retention rate or something. I don't know. Cause right now, I like the fact that I don't have a lot of reviews every day, but I don't know if it's I don't know if really feel too proud. What is entropy? Entropy is the spontaneous dispersal of energy at a specific temperature. Oh, what's going on? Oh, um, okay. So, what in the? Okay. So, yeah, all right, that's correct. How do we calculate the change in entropy? Um, Q divided by T. Hard. Um, what is bond dissociation energy? It is the energy required to break a bond um, for a substance in its gaseous state. What is the equation to calculate Gibbs free energy? That's going to be delta G equals delta H minus T delta S. Good task. All right, what is the second law of thermodynamics state? It states that in a spontaneous system, I don't even know what the first law says. It says that the system, um, in a spontaneous process, the entropy of the system or the universe will always increase. What is the standard enthalpy of combustion? Standard enthalpy of combustion is mm, um, the standard enthalpy of combustion is um, the heat required for combustion to occur at a constant pressure. And obviously in standard state. Is a reaction always spontaneous? No. Um, how does one how does one find the enthalpy of a reaction using only bond dissociation energy? Um, Energy of bonds broken minus energy of bonds formed. How do we calculate the standard Gibbs free energy for a reaction? Um, Bro, it's probably products minus reactants again, bro. See, what did I say? What did I say? How does one relate the equilibrium constant for a reaction and the standard Gibbs free energy of the reaction? Um, well, the spontaneity of the Gibbs free energy would probably have something to do with the equilibrium constant, I'm thinking, because the higher the or the lower the standard Gibbs free energy, then you're gonna have it's gonna be more spontaneous, meaning that it's gonna lean more towards the product. So the equilibrium constant would be a higher number. Oh, I forgot about that equation. Negative RT, natural log of KQ. No, it might depend on the temperature. No, it might depend on the temperature. How can we calculate the standard entropy of a reaction? Um, How can we calculate the standard entropy of a reaction? Um, this is probably products minus reactants again, bro. Figured. The spontaneous dispersal of energy at a specific temperature. How does one relate the, this is going to be negative RT natural log of KQ. How do we calculate the change in entropy? Um, Q divided by T. How do we relate standard gives free energy and non-standard gives free energy? I don't know. This isn't an equation. Like, this means that the other one can be manipulated. So when this is equal to zero, which means that it's at equilibrium. This is zero at equilibrium. So then this turns to K. And we would just bring this over to the other side. And then boom. Easy pickings. Um, what are the four variables that define the state of a gas? Pressure, volume, temperature, and moles. PV equals nRT. What is a barometer? It measures pressure. What is an ideal gas? Um, it follows all the properties of an ideal gas. I don't know. Zero volume, zero IMFs. Um, what is the ideal gas law? PV equals nRT. What is Boyle's law? I don't know. All right, so let's see if we can come up with something to figure this out. So pressure and volume of the gas are inversely proportional. Okay, so basically, Boyle's law can be kind of like thinking about water in a pot. When you have water in the pot, then oh, nice. Okay, when you have water in a pot and it starts to boil, obviously it's gonna start going up. It's about to, so it'll like expand. So I think we can think about Boyle's law as literally boiling. So PV is gonna be equal to PV. All right. Now let's see. Let's see what happens when we're gonna go again. How does one relate standard gives free energy and non-standard gives free energy? There's gonna be delta G is gonna be equal to delta G naught plus RT ln Q. What are four variables? Pressure, volume, temperature, and moles. An ideal gas has zero volume and experiences zero IMFs. How can we calculate the standard gives free energy for a reaction? It's gonna be standard. Standard gives free energy a formation of the products minus the reactants. What is bond dissociation energy? It is the energy required to break a bond for a substance in its gaseous state. What is the equation to calculate Gibbs free energy? Um, it should be delta G is equal to delta H minus T delta S. What is Boyle's law? PV1 is equal to PV2. I could be saying P2V2, but I just don't want to. Get it? See what I did there? What does the second law of thermodynamics state in basic terms? It says that in a spontaneous process, the in a spontaneous process, the um, the enthalpy or not enthalpy, the entropy of a system or the universe will always increase. Is a reaction always spontaneous? Sometimes it might differ by temperature, so no. What is Charles' law? I don't know, but let's figure it out. Charles. How can we relate Charles' law to volume and temperature? Hmm. Mm, what can we think of for a mnemonic for Charles' law? Um, I feel like I'm being led astray here. Okay, we've been getting scammed. Boyle's law does not, in fact, say. Boyle's law doesn't say that. Um, where in the world? Where did we jump to? Oh, oh, never mind. We have not been getting scammed. Sorry. Um, Charles' law states that Charles' law states that volume and temperature are proportional. Okay, so does Charles sound like a guy? I know. I watched someone. I watched someone named Charles. I could think about me watching him on a TV, but I don't watch him on TV. But he watches TV, so that might count. That might count. We could say that. But then it might get confusing because it's not TV. It's more like BT, B over T. Um, 1 second. Okay. All right. We can click again. How do we gonna relate that equilibrium constant is gonna be delta G is equal to delta G naught plus RT ln q. Damn, I look need to remember that the gas constant uses different units. Bro, it's not Q. No. Wait a minute. Wait a minute. Wait a minute. What? Oh man, I put the wrong one. How do we calculate the entropy? That was funny. How do we calculate the change in entropy? Um, to calculate the change in entropy, Q divided by T. What is the standard enthalpy of combustion? Um, Standard enthalpy of combustion is the heat required to for a substance to combust in standard conditions and their constant pressure. What is the ideal gas law? What is the ideal gas law? The ideal gas law, it says that they have molecules have zero volume, like in their gaseous states, obviously. They have zero volume and zero IMFs. Yeah. Oh my god. I cannot believe this. What is an ideal gas? Oh, this is the question that I thought the last question was. Charles' law is V over T is equal to V over T. I should have said that they're proportional. How does one relate standard Gibbs free energy of a reaction and non-standard Gibbs free energy of a reaction? Um, this one was the one that I was drawing before. Delta G is equal to delta G no plus RT ln Q. What are the four variables? Pressure, volume, temperature, moles. What is Boyle's law? PV equals PV. They're inversely proportional, yes. How does one relate the equilibrium constant for a reaction and the standard Gibbs free energy of the reaction? Um, um, it would be delta G naught is equal to negative RT ln K EQ. I'm done. got this right. What is entropy? Entropy is um entropy is spontaneous dispersal of energy at specific temperatures. What is the ideal gas law? Ideal gas law is um uh is PV is equal to nRT, where the R is gonna be it's still gonna be 0.08, I think like 21 or something. Yeah. What is bro? I did not press undo. What is Charles' law? Charles' law is V over T is equal to V over T. They're proportional. Volume and temperature are proportional. How can we calculate the Gibbs free energy for a reaction? Um, how can we calculate the standard Gibbs free energy for a reaction? Um, the products minus the reactants. A formation. What is Gay-Lussac's law? P over T. Uh, okay. All right. I'll just remember it, bro. What are real gases? I mean, real gases, obviously, they're just going to have the opposite. They're not going to have the opposite per se, but like, I'm just going to assume that real gases would just be the gases that do have volume, that they do experience IMS. Yeah. Real gases. The ones that exist. What a shocker. No, it can depend on the temperature. No, they do not. Well, it didn't. It didn't. I feel like, damn, that was low key on me for assuming. To be honest, I can't even say anything. Oh, that's interesting. So, I mean, we kind of just saw. Um, so Boyle's law looks at high and low V. Those are basically like equivalent. They both are the same thing. They have the same result. High P basically means you have too low of a volume to accommodate all of the, or like to accommodate the energy that the particles have. So I figured that the T, obviously, if you increase T, then you're gonna have more energy within the molecules. So I figured it would probably have something to do with that, but it doesn't. So at low temperatures, the gas molecules themselves are going to slow down, and that's gonna cause IMS to work, and that's why they don't work. That's why they don't behave ideally at low temperatures. That's interesting. I don't know if I really explained that properly, but I want to pretend like I did. This is gonna be P over T is equal to P over T. What are real gases? Gases that have volume and experience IMFs. They're gases that exist in the real world. It is a gas that it does not experience IMFs and has no volume. What is Dalton's law of partial pressures? What is mole fraction X? I'm gonna try to get. I'm gonna try to make a guess. Hold up. I mean, I think there's two answers here, but you could do the partial pressure of one element. We're gonna pretend like that's a normal E. It's like a over P total. That's one, and the other one is obviously gonna be, or not. I guess not so obviously, but obviously the moles of the substance over the total moles. I feel like it can be either one. It can be either one. They're the same thing. Do real gases follow the ideal gas law? Um, um, yes, but not at all ranges. A high, if you have a high P, a low V and T, then it won't work. Ideal gas law is PV equals nRT. What is Dalton's law of partial pressures? Um, it says that the total pressure is equal to the sum of the individual pressures. What is Charles' law? Charles' law says V over T, so volume and temperature are proportional. How are mole fraction and partial pressure related? You see, there it is. I mean, yeah, I kind of know that. How do we calculate the change in entropy? Um, uh, how do we calculate the change in entropy? Um, uh, Q over T. What is kinetic molecular theory? Um, Okay. All right, we're gonna need to like dissect this card. Particles with negligible volumes. No IMFs. Continuous random motion and collisions. Elastic collisions. Okay. So particles with negligible volume compared to the container. Um, Kinetic energy. We're having a lot of primacy and recency. Um, you have the we're gonna have the average kinetic energy of the particles is proportional to the absolute temperature of the gas. The collisions are gonna be elastic. The particles are undergoing continuous random motion, undergoing collisions, and I think one or two more. Oh, no IMS, and I said everything else. Oh, that was it. Okay, okay. All right, we'll click again, and I'll wait for next time. Pressure, volume, moles, and temperature. PV equals PV. Hydrogen standard. It's gonna be delta G is equal to delta G naught plus RT ln Q. This is a series of assumptions used to describe ideal gases. Let me look up the definition of this real quick. It's gonna be P over T. How does one relate the equilibrium constant for a reaction and the standard gives free energy? Delta G naught is equal to negative RT ln K. So the gas particles have a negligible volume compared to the container. They do not experience IMFs. Um, they undergo continuous random motion, undergoing collisions. Collisions are elastic, and the average kinetic energy of the particles is proportional to the absolute temperature of the gas. What is the mole fraction? Um, Moles of that substance divided by total moles. Do real gases follow the ideal gas law? Not at high pressure or low volume or low temperature. What is Dalton's law of partial pressures? Um, Let me look something up. Mm, okay. Anyways, what is Dalton's law of partial pressures? It says that the sum of all of the partial pressures is equal to the total pressure. It's a series of assumptions used to describe the behavior of gases. I know this. I'm not even gonna. What are real gases? Gases that do experience IMFs and that do have a volume. What is an ideal gas? It has no IMFs and has no volume. The higher the temperature, the faster it'll move. Easy. The larger the molecule, well, probably the slower. Yeah. What is the ideal gas law? I love cards like that. They should give me some more of those. What is the ideal gas law? Ideal gas law is um the ideal gas law is okay, it's just PV equals nRT, where R is 0.0821. What is diffusion? It means that it just passes through some permeable membrane. Um, or like it's the movement of particles following the concentration gradient without using energy. Yeah, I mean spontaneous. Yeah, same thing. That's natural. Is the point. What is it? What is effusion? Flow of a gas particle under pressure from one area to another through a small opening. Charles' law is going to be V over T. This one's going to be P over T. Heavier gases diffuse. I mean, if the kinetic molecular theory makes any sense, like I'm not even gonna think about the assumptions, just so that I could have a shortcut. Or maybe I should think about both. All right, we're not gonna take the shortcut. So it should be the case if it's a heavier gas, it should diffuse slower because it moves slower. Um, we have the assumptions state it has no IMS, no volume. They collide elastically, and I feel like none of those really answered anything. I'm just gonna go with slower. Yeah, figured. What is effusion? It is the flow of a gas from one compartment to another, or from one area to another through a small opening. Okay. Um, what is Graham's law of effusion and diffusion? Okay, interesting. Compare the diffusion and effusion rates between gases by relating the square root of their molar masses, where R's are the diffusion or effusion rates of the two gases, and okay. As pressure on a liquid goes up, I love these questions. As pressure on a liquid goes up, solubility of gases in that liquid. Um, I mean, I would think it would increase, right? Yeah. It was a little hard, I will say. Is the flow of gases under pressure to move from one compartment to another um, through a small opening. What is a mixture? I feel like it's self-explanatory, to be honest. I'm suspending this card. There's just no formal definition. That's not a formal enough definition for me. But what is Graham's law of effusion and diffusion? This is gonna be we have R1 over R2, I think. It's gonna be equal to the square root of M2 over M1, right? I think. Yes. And then the R's are gonna be the diffusion or effusion rates, and the M's are gonna be their molar masses. What is a solution? It is a homogeneous. Uh, no, I think it is. Is it homogeneous? Is it always homogeneous? Yeah, figured. Man, what are the two components of a solution? The solute and the solvent. What is a solute? That's the thing that's mixed into the solvent. You're dissolving that in there. What is a solvent? That is the thing that's you mix the solute into. The compound is mixed into the solvent. Okay, I'll leave that one alone just because I gave an unexpected answer. An aqueous solution. It's a solution that is for which the solvent is in the liquid phase and the solute was mixed into it. Oh, uh, salvation is like it dissolve when you dissolve like a substance and um, you dissolve a substance, bro, and it forms like the solute forms. There's another card like this. It literally asked me the same thing. When that card pops up again, I'm not gonna know what it is. It forms like a layer around the initial particle. See, this is kind of like what I was saying, but I'm not gonna lie, this is not what I was picturing. I'll be honest with you. That's unfortunate, to be honest. Um, One second. Let me see something.
Welcome home, Columbia. Beautiful, beautiful. Discovery 4 computers now have primary control of critical vehicle functions.
Okay. All right.
Discovery Houston, prep to ATO.
What is a solution? A homogeneous mixture of solute and solvent. Oh.
Beautiful, beautiful.
What do real gases follow the ideal gas law? Not necessarily. Yes, but not at all ranges. So at high pressure, low volume, and low temperature, they don't follow the ideal gas law. Um, they do not take up volume. Their volume is negligible compared to the container. They do not experience IMS. They experience continuous random motion undergoing collisions. The collisions are elastic, and kinetic energy is kinetic energy is the average kinetic energy is proportional to the absolute temperature of the Average, the absolute temperature of the gas. Not even gonna bother saying that one out loud. Um, what is the solvent? It is it's the part of the solution that stays in the same phase. What is an aqueous solution? What is an aqueous solution? It's a solution in which the solvent is water. Electrostatic interactions between solvent and solvent. What is a solution? It's the component. Wait, no. This is a homogeneous mixture between two or more substances in the same phase. The total pressure is equal to the sum of all the partial pressures. As pressure on a liquid goes up, solubility of gas in that liquid increases. How mole? Okay. What is the kinetic molecular theory? Um, um, Kinetic molecular theory is a series of assumptions to explain the behavior of gases. Graham's law of diffusion and diffusion is um um Graham's law of effusion and diffusion. It says that damn, the playback is running on the like YouTube because I have the YouTube like tab open above, and it just so happened that that card popped up above. Luckily, I saw the picture, but I didn't read anything. What is Graham's law of effusion and diffusion? Um, it's R1 over R2 is equal to, or I didn't see the picture, the the picture of the equation either. So um square root of m2 over m1. What is diffusion? Uh, Diffusion is movement of molecules without use of any energy, um, following like their concentration gradient. The kinetic molecular theory states that heavier gases diffuse slower. P over T, they're proportional. How does salvation occur? What is effusion? It's the flow of gas molecules from one area to another. Um, okay, guys, hold up. Give me like, I don't know, like 5 minutes or something like that. Give me a second. gonna take a mini break. So let me switch my screen in a second. Um, right. Beat the bot. All right. So we're gonna go. Could be trade. It could be trace. Just run it. Damn. It was a 50-50, bro. How many did I do better or not? The average was still 3.1. Damn. Okay. After the first, you see, literally it was just trade and trace. That everything. The most people pick a do. Most people also just went trace. Most people got it today then. Okay. All right, let's play connections. Um um mm, Because I'm looking at this, I was like, okay, in the movie titles. Then I look at these. Both of these have to do with time. There's nothing else there. Showtime. I was like, okay, maybe we have channels. Not that. Sundance Karate. Okay, maybe it's like moves. Nothing else has to do with moves. Oxygen. Like what? Like what? Like there's no other. Like what? What could oxygen have to do with? I look at oxygen. I see Gen. Okay, maybe something there. Nothing. Um. Then curtain up, 5 letter W words. Not that. Uh, once in a blue moon, once in a lifetime, once in a while, once in a generation. Let's try it. Yo, oh my God. Okay. Uh, let's see. Um, Showtime, curtain up, action, and bro, this is it's like all different ways of saying like something's gonna start. Oh, places, places, people, places. Um, Things that you need: water, sleep, oxygen, nutrition. Yo, that got to be the fastest connections game I think we've ever done. What else do we have? We can do the mini. Let me try the mini. Um, Damn, this is a big mini. It's Friday. Gets right down. I don't know. Origami. It's obviously paper and pencil, but what does that have to do with this? Written, that, yum, specialized as majored, small hair, eyelash. I don't know. Yow. Roth, IRA, Vin, sunny part, sunny, egg yolk, warrior with a katana, a samurai. My life is all over the place right now. I'm a mess. I don't know. What the hell is a Wang Ma? What? This is obviously Kiss, but I don't. What is that? Um, what is that? What? Yo, I am not getting. I don't know if I can get either one of those. Uh, uh, oh, dives in. Um, I still don't know what that is. Okay, I don't know what that is. I call Mew. Oh, wet kiss. Um, what the hell is that, bro? That was cheating a little, but what? Everything else makes sense. is shout? Uh, can I reveal this? What is this? Oh my gosh. Um. Ugh. Okay. Okay. I almost just started. Anki, 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 Anki. Okay. What is a fusion? A fusion is a fusion is movement of particles from like under pressure from one area to another through a small opening. An aqueous solution solvent is water. How does solvation occur? Basically like electrostatic interactions between the ions and the solvent molecules basically disrupt those same electrostatic interactions between the solvent molecules, so it dissolves pretty much. What is solvation? Electrostatic interaction between solvent and solute molecules. What is a solution? Homogeneous mixture between two plus two or more solutes and a solvent. It's the component that doesn't change phases. As pressure on a liquid goes up, solubility of gases in that liquid is gonna increase. Yeah, increase. Um, R1 over R2 is equal to the square root of the M2 over M1. What is hydration? What happens if solute-solvent interactions are not stronger than the intermolecular forces in the compound? It probably won't dissolve as well. Oh, just won't dissolve? Okay, cool. How does entropy always change during salvation?
Discovery Houston, press to
Um, so
liftoff of mission 41B, the first flight of the Orbit Discovery, and the shuttle has cleared power.
oh. I didn't mean to do that. My bad. So
Discovery, go and throttle up. Discovery's 4 computers now have primary control of critical vehicle functions.
I think entropy kind of has to decrease because it just becomes more. It becomes a lot more organized. But I know that like we literally just saw that it has to increase. But I just don't know. I don't remember how it increases. Mm, uh, okay, so this card is just a lie. So basically, let me change it and then I'll explain it. So pretty much, so the ions when they dissolve, they go from this like crystal lattice to form like obviously they're going to become a lot more spread out because it breaks the crystal lattice apart. So it's going to be all in these like all disordered, so the entropy would increase there. However, the water is obviously becoming more ordered, so it just at the end of the day the entropy change just simply depends on which one, like which one was stronger, the gain of entropy by the solute or the loss of entropy by the solvent. So what is a solution? It's a homogeneous mixture between uh, s- two or more substances in a solvent in the same phase. What is hydration? It's solvation, but in water. It doesn't dissolve. What determines something's solubility in a solvent? KSP. It's KSP. Oh, if the is solubility? What does it mean to be an unsaturated solution? It means that more solute can still be dissolved. What does it mean to be a saturated solution? It means that if you were to put more, it wouldn't dissolve. What does it mean to precipitate? It means that it forms a solid, no? What does it mean to be a supersaturated solution? It means that um it actually has more um solute than might be expected. Um yeah, I don't know. I don't even know what the ion product is. What is it? Um it's based on thermodynamics. If the electrostatic interactions between the solute and the solvent are stronger than solute to solute, then it'll dissolve. If not, then it won't. What is solubility? Solubility is the maximum amount of substance that can dissolve in the maximum amount of substance that can dissolve in a solvent at a specific temperature. It means that if you add it any more, it'll either remain in a solid state or go into it. What does it mean to precipitate? It means it's going to remain or go into a solid state, bro. What is an aqueous solution? It is a solution where water is a solvent. How does solvation occur? Solute-solvent interactions, electrostatic interactions are stronger. So the solvent surrounds the solute in order to dissolve it. What does it mean to be a supersaturated solution? It means that the ion product is higher than the KSP, which is done by pretty much using heat to raise the KSP, dissolving more substance and then slowly cooling it down. So there's more of a substance than realistically would be expected. Salvation is what is the molar solubility of an ion in molarity and its concentration of an ion in its saturated solution? What are the 7 general solubility rules for water? Oh, brother. I hate this. let's check this. I'm not. I'm not getting up yet, but I just want to see where we are. Okay, we started here. We're here now. We still have acids and bases left. 25 cards left in the gas phase one. Okay. How does entropy always? Oh, sorry, I didn't mean to do that. Okay. How does entropy always change during salvation? Um. It doesn't always change. It's just like it depends which one changes the entropy the most, either the gaining of order to the water or the loss by the solute. What is solvation? Electrostatic interactions between the solute and the solvent. Um, in molarity, the concentration of solute that dissolves in the solvent. Uh, like I don't feel like that was worded specifically enough for me. What does it mean to be an unsaturated solution? It means that if you added more, it would work. If you added more, it would dissolve. Oh man. Um, there's no way. There's no way that I'm remembering this. I need to get the chart. Let me get the chart. they put this song on literally every single one of their videos. Um, I'm looking for a chart that has the solubility rules in a very like in a succinct way. Like, um, this is very annoying. This is gonna take forever to memorize. Forever. it's crazy because like the solubility rules, I feel like I'm looking at like there's all these charts saying like, oh, this is soluble, this is not soluble, blah blah blah, and they have like low key different opinions. Like, how do you have different opinions? Is it a fact or not? Like, um, okay, so it's gonna be nitrate. There's gonna be NO3. If it's containing NO3, uh, NO3, NH4, any of the group ones, sulfate is uh, going to be soluble except for um, it's gonna be soluble except for Castrobear and lead, mercury, and silver. And then we're gonna have ammonium as always. And then what is the other G? Oh, the halides. Halides are gonna be soluble except for I think PMS. Okay. That's weird. Okay. Um, I'm not gonna lie, I'm pretty tempted to bury this until tomorrow. I might bury this just so we can not lose our pace. I'm gonna bury it. Actually, no. I feel like we're already so far. And then metal oxides are gonna be insoluble except for Castrobear and the usuals. Hydroxides are insoluble except for Castrobear and the usuals. And then can't have carbonate, phosphate, sulfide, or sulfite, except for the usuals. Okay, so we have nitrate, um, C2H3O2, um, group one, sulfate, except for Castrobear and PMS, and then uh, ammonium, and group 17, except for except for PMS. And then insoluble, all metal oxides are insoluble except for Castrobear and the usuals. All hydroxides, I think, are insoluble except for Castrobear and the usuals. And then all sulfides, carbonate and phosphate are insoluble except for the usuals. All right. Well, that took so long to do. My controller literally turned off. It disconnected. Um. Oh, that was quite draining. Molar solubility is the amount of moles. We're gonna push. We're gonna push through. I'm not doing this. At least for a little while longer. What is the molar solubility? Um, molar solubility. Oh, don't you dare look back. Type of beat. What is the molar solubility? It is the concentration of the solute after like at maximum saturation. What is the concentration of the solute? What is solubility? The maximum amount of substance that can dissolve in a solvent at a particular temperature. Damn it. What it means to precipitate, it means to remain or go into a solid state rather than dissolving. It doesn't dissolve. What is a solution? A homogeneous mixture with two or more substances in the same phase. What is hydration? It's solvation, but with water. What is solvation? Electrostatic interaction between the solute and the solvent. The strength of the interaction of electrostatic interaction between the solute and the solvent. It means that no more of that substance can dissolve. Yeah, I'm still correct. It's not maximum amount of dissolved ions. It's maximum amount of dissolved of that type of ion. So as long as it doesn't have an ion in common, it's still capable of dissolving other salts technically. What does it mean to be supersaturated? It means that you went about some super complex procedure in order to dissolve more substances than realistically it should have been able to. What does it mean? It means that the ion product, yes, it was higher. Yes, I know I technically just looked at the card, but it's fine. I didn't really read it. Words an unsaturated, it means that if you tried to add more solute, it would dissolve. it doesn't always change. It's not always like it's not that it doesn't always change, but like it's not always positive or negative. It just depends on how on like the weight of each one of the solute and the loss or gain of order. So this is the nitrate. Nitrate's always soluble. Um uh Acetate or C2H3O2 is always soluble. Group 1 is always soluble. Sulfate, except for PMS and Castrobear. Ammonium is always soluble, and group 17 is soluble except for PMS. Then all metal oxides are insoluble except for Castrobear and the normal. All hydroxides are insoluble except for Castrobear and the normals. And uh, carbonate, carbonate, phosphate, sulfite, and sulfide are all insoluble except for the normals. What is solubility? Solubility is the maximum amount of substance that can dissolve in a solvent at a particular temperature. What is a coordination compound? It means one of them gives all the electrons for the bond. Please hold. I think I might have confused this with whatever I'm talking about before. Oh no, I'm confusing with a coordinate covalent bond. So I guess I wasn't that far off. Um, what is a ligand? It is a molecule bound to is a molecule bound to um oh my gosh. Ew. I don't even know how to refresh my brain right now. Like, we literally did 50 cards. And this is where I'm like genuinely wanting to just stop. Like I want to just stop right now. But I know that I shouldn't do that. I really wanted to finish a lot of this, or all of it, to be honest. So 23 cards and solutions remaining. Let me see which cards it is. Um, I don't think this. I'm not gonna lie. It's not looking like I ordered this one. I thought I did. Maybe I didn't though. Let me see something. Oh, it was ordered apparently, but or maybe it wasn't. Never mind. Um, okay. Um, let me see something. We were literally, we literally took a break like 20 minutes ago. All I'm gonna say is I do not feel healed. I don't feel healed at all. Um, if I continue, I'm probably gonna be pretty inefficient. But I really do want to finish, bro. Maybe I should try to finish these last like 23, and then after that, just like I don't know, just call it. Just call it after these 23. What percent of chemistry have we done now? 71. Okay, hold up. Let's I don't know. Let's put 0 new cards. Let's finish these. Let's finish these 6 right quick. Well, we're not gonna stop, but we're gonna see if we switch it up a little bit at least. What is a coordination compound? Uh, a coordination compound is it has a central cation and electron pair donors surrounding it. Yeah, but it has to have at least one. What is solubility? The maximum amount of substance that can dissolve a in a solvent at a particular temperature. It's the concentration of solute at in a saturated solution. It means that when you try to dissolve something, rather than dissolving, it just remains or goes into a solid state. What is solvation? Electrostatic interactions between the solvent and the solute. means that there is a cation that's bound to at least one electron pair donor. You have nitrate is always soluble, ammonium is always soluble, acetate or C2H3O2 is always soluble. Group 1 is always soluble. Sulfate is PMS and Castrobear are the exceptions for its solubility. Then halides or group 17 are they're soluble except for PMS. And then all metal oxides are insoluble except for Castrobear and the normal. All hydroxides are insoluble except for Castrobear and the normal. And all of sulfide, phosphate, and carbonate are all insoluble except for the normals. What is a coordination compound? Is also known as uh, damn, hold up. I tried pulling one of my nails out. Hold up. Let me, let me, I'll be back. Give me a second. coordinate covalent compound is it has a cation, a central cation, and it's bound to at least one electron pair donor. It's also known as a complex ion. What is solubility? The maximum amount of substance that can dissolve at a particular temperature in a solvent. Okay. All right. So now we're gonna bring this back up to 300, but I just wanted to get rid of those reds. Okay, so we're down to 131. Now what we're gonna do is I don't know. We're just gonna switch it up. I just want to do something else, something that's not this. I think I'm done with chemistry for the day, or my brain is done with chemistry for the day. I cannot be bothered to do that any longer. Mm, sorry guys, I'm really trying. I'm really trying to see if I can find something that I can do right now. I'm trying to I'm trying to fight to do as many cards as possible today. already know. Let's just do the math. A long time ago, I said I was gonna do this math eventually. Today's gonna be that day. What is 13 squared? 169. What is 14 squared? Uh, Yikes. Is it 196? Whew, I was not expecting that. How do you approximate the value of a non-perfect square? Just look at its surroundings. What is log? Um, I mean, it's something like a reverse operation for a power or for like exponential expressions. I don't really like this question. Suspend. Log is the reverse. That's what I was saying. That's a more valid question. It's much more important. What is the log of any base of 1 equal to? So the way it works is log A of B is equal to C, but A to C power is equal to B. So log sub A, and it's saying A to what power? A to what power is equal to 1. And the answer is always going to be 0. What is log base A of the same number A? So it's basically asking A, like I said, to what power is going to be equal to the same number? The answer is 1. What happens when you take the log of the product of two numbers? Um, I think you can add the logs up. I might be bugging. Yeah. You could subtract them. Log A minus log B. Why when you take the log of a number to the exponent? You can move the B over there, so it'll be B log A. Why when you take the log of a denominator, you could put -1 log A. Same thing. Whenever a log, it's 10. What is the common log? If it's the same, is that a natural log? Like, what? I'm suspending this card. What is a natural log? It's the log with a base of E. How do you solve for variables in the exponent of Euler's number? So this is basically saying EX is equal to Y. So it's saying, how do you solve for X? And it's going to be doing natural log of both sides. Take the natural log of both sides. What are the values of sine and cosine at 0, 30, 45, 60, and 90? So this is going to be, you pull out your right hand, and you just, first one, so we're going to have cosine and sine. It's going to go cosine and then sine. So of zero is just going to be, is going to be 1, 0. Then it's going to be square root of 3 over 2 and 1 over 2. And then square root of 2 over 2 and square root of 2 over 2. 1 over 2 and square root of 3 over 2. And 0, 1. That should be right. Yep. What is a direct relationship? A direct relationship is like if one increases, then the other one increases too. They directly affect one another. What is an inverse relationship? When one increases, the other decreases. What is pico? I think pico might be like pico. I think is -10, low key. I'm gonna go with -10. Damn, 12. See, that's why I left that there. Centi is -1. Yeah, I didn't hear that. Yeah, I didn't hear that. Just pretend like you didn't hear that. Deci is I don't know. I'm gonna go +2, bro. Please. Oh my god. Deca. Is this one +1? Never even heard of that. Um, what is an angstrom? Its converting factor is the same as a picometer, so it's 10 to -12. Damn, bro, it's not. Yo, -2. Pico is -12. 10 to -12. Deci is -1. Deca is +1. Angstrom is 10 to the -10th of a meter. It's gonna be 1. What happens when you take the log of the product? You can add up both of the logs. You can subtract them. But you put the -1 at the beginning. It's log with the base of e. 196. Pico is 10 to -12. Log is the inverse. Deci is Deci is gonna be Deci is gonna be this is gonna be -1, +1, -2, 0. Put it at the beginning, 10. It's proportional increases. When one increases, the other one increases proportionally. The other one decreases proportionally. What is 10 to -10th of a meter? It's 1. You can add them. Log base of the e. You can subtract them. Put the -1 at the beginning. 10 to -12. 10 to -2. 10 to -1. 10 to the +1. Fantastic. You see, that is what we like to see. We needed something on the board, man. We needed something on the board. We needed to have something. I couldn't just leave that. I couldn't just leave that there, bro. Um, I could do another physics one, but I'm debating it right now. Um, um, damn. Yeah, to be honest, I think that's it for today. To be honest, we tried. I agree. We've done a decent amount. Not anywhere near as much as I wanted, clearly. But um yeah, one of these days I'm gonna come in and I'm gonna do a lot more. Um I just have to push through. But I think I am done for the day. So I hope that everyone has a nice rest of their night, day, evening, and any other word that pertains to the time of the day.